1 minus. Are we good on that? I want to practice this some more with a new problem. That's all well, there's two little things at the end that are not at all challenging.
Okay, how would I put that? Would it be .850 or point?
Oh, I don't know. Is it
Yeah.
8? Oh, yeah, it would be 850. My bad.
Okay. I've always been like,
No, I didn't do it right. Now are we good? Now that I can round correctly? Those aren't doing me any good.
I was going to say, what is this?
Find some more blank paper here.
You can do the rest of my notes for me.
Let's see. Oh, here's some. Found some.
Care?
Okay, let's try another one.
I gotta get the notebooks.
Okay, 21% of men pick fishing as their favorite leisure time activity. What's 21%? Yeah, because I got like A, B, and C.
Oh.
You are going to select 6 men and ask them what their favorite leisure time activity is. If they pick fishing, it's a success. If they pick something else, it's a failure. What's the probability of me getting exactly 3 men to say they like fishing out of my 6? What's my calculator line going to be? Binom what?
PDF.
Is it a PDF or a CDF?
PDF.
PDF, because I'm not adding any probabilities together. So this is like what you have to do on the test. You have to give me that, and then the numbers you're entering in, which is 6, comma, 0.21, comma, just 3. Exactly 3 successes. And it will give me that one probability. What is it? 0.91. So only a 9% chance.
wait, why did you use PDF?
Because I'm not adding any probabilities together. I only want one outcome of getting exactly 3. I would want like this one number on my table. Okay? Okay. Now let me make it challenging again. That was Friday's stuff. What's the probability of getting fewer than 3? I always like to write down what this actually means to me. Which probabilities am I looking for if I'm talking fewer than 3? What outcomes mean fewer than 3?
0, 1,
0, 1, and 2. What most people do that make mistakes is whatever number they see, they just stick that on the end. You've got to think about these and decide. Is 3 included in fewer than 3? No. So this, because it's starting from 0 and adding, it's a CDF. If it starts at 0, I don't have to do a 1 minus. If it's not starting at 0, then I do have to do a 1 minus. But this one is starting at 0. So that's 6 trials, 0.21 success. What's my X number? Is it 2 or is it 3?
2.
It is 2. It is this number. It gives me 3 probabilities added together, but the X value is the number of successes. It stops at 2. Not how many probabilities, but successes. And what did this one come out? 888, quite a high probability. What's the probability of getting at least 4 of the 6 men to say they like fishing the best? Tell me what numbers mean at least 4 in this case.
4, 5, 6.
At least 4. Is 4 included in at least 4?
Yes.
So I want 4, 5, and 6. Can you get the CDF to start adding at 4? No, it starts adding always at 0. So this tells me I need that 1 minus this bottom chunk. I want to subtract off this. This is my CDF right here, chunk. So because I'm starting at 4, I know it's a 1 minus, the lower chunk. Binom CDF. So this is the part I'm subtracting off. I'm doing 6 trials. 0.21. What's my X number?
3.
The last one in the box that I want subtracted off is a 3. Now it helps to write this out. I think this is key. Dylan, a little tired, stay up late this weekend?
Yeah, I should.
Anybody crank through this yet?
0.020.
Yeah, 4's the one I want. This is the part I'm subtracting off, minus this chunk.
0.020.
Because this will add 0, 1. See? I like to write out the ones I want to keep and the ones I want to subtract off. This is my CDF part here. This 1, 2, and 3. 0, 1, 2, and 3. Now what did this come out?
0.020.
Let's try one more of these. Let's go. Yeah, if you can start wrapping your head around these phrases, and when you do a 1 minus and when you don't, you're going to walk right through this test and say, well, I had a spring break and I did really good on that test. More than 2 of the men to say they like fishing the best. Tell me what numbers mean more than 2 in this case. Derek.
3, 4, 5, and 6.
3, 4, 5, and 6. Because it's starting at 3, what does it tell me I'm going to be doing? I'm going to be doing a 1 minus. And the 1 minus chunk is 0, 1, 2. This is my 1 minus. I want to subtract off that bottom chunk. So this is, again, a 1 minus. 6.21. Here's where you lose your points on the quiz. Test. 2. Yep. Yeah, because we had that other answer there. What is this coming out to be? Okay, that's enough. There's 2 other little things in here. You know how I had to do the mean and standard deviation on the last 2 problems? Or the book had you do that? You had to do the list 1, list 2, 1 bar stats.
Sure.
We have a shortcut for that today too. And I don't care which way you do this.
How much makes it?
About 4 lines.
How much does this mean?
4 lines. Shortcuts for mean, variance, and standard deviation for a binomial probability distribution. The mean, mu, the formula for that is just n times p, the number of trials you're doing times the probability of success. The variance which is our sigma squared, is just n times p times q. And the standard deviation, you should be able to tell me, what's the relationship between these 2 things? Square root of n times p times q. Okay, we're going to do one of those in a minute. Do you have a question yet? Yep, you'll find out in a second here. Okay, and then the last thing is the shape of a binomial distribution. Your binomial distributions are either going to be symmetric, skewed left, or skewed right.
Just like
Yes. And it's all based on the probability of a success. If the probability of a success equals 0.5, exactly 1/2, what shape do you think that one's going to have? It's going to be symmetrical. The shape will be symmetrical. Oh, I can almost fit that on there. That says symmetrical.
I guess it's more than 25.
If it's less than 0.5, which means the probability is small,
Less than skewed right.
you're going to have more successes down on the low end, like when X is 0 or 1, because it doesn't have a high probability of happening. So it's going to have a lot of successes on the low end, and then it's going to tail off as it gets out higher. What kind of skewed is that?
Right. Skewed right.
It's where the tail is at. It's skewed towards the tail, so it's skewed right. And then the last one is if your probability of a success is greater than 0.5, it's going to be a few successes here, more higher end, skewed left. And then our last one, so it's going to be incorporating these two things.
Wait, that wasn't it?
No, I got one quick example left.
So I totally could have just written a new page instead of
Yeah.
the bottom.
Whose fault is that?
Yours.
Okay, this is it.
Cramming it all down here, like arrows and
So from example 2, can you find the mean, variance, and standard deviation for the number of people out of 6 that would pick fishing as their favorite activity, and the shape of the distribution? So we don't have to graph it to tell what shape it's going to have. So we'll go with mean first. It was a simple formula. It's just n times p. What was n in that problem? We were picking 6 men? Yep, 6 men. Probability of success was 0.21. I would expect an average of 1.26 out of 6. Number of trials. I picked 6 men. Okay. Variance is n times p times q. N is still 6. P is still 0.21. What was q again? A probability of a failure. If it's 21% success, that means, well, how much? 79% failure. They have to add up to 100% successive failures. Because you either succeed or you fail altogether. It's 100%. So 79. That does not make 1 either. A lot of the confusion there, when you multiply, you get 1. You don't when you add, you get 1, but not when you multiply. 995? Okay. And then standard deviation? Yep. Take the square root of that. Eight? I think it depends on if you chopped off the 5 or if you used the whole answer from the last one. Close enough. I don't mark any of that stuff wrong. And what shape, if I was to graph this distribution and make the whole table and graph it, will it have?
left.
You're right.
I heard left and right.
It's right.
It's greater than 0.5.
It's 0.21. The P equals 0.21.
Oh,
Which is
it's about the P, okay.
The P. It's all about the P, the probability of success. So